So for the opening speaker, we have Devlin here, who actually wrote a few books on full stack development, is like an Microsoft MVP, and he's actually been in the industry for quite some time and has speaking experience. So I would like highly encourage everybody to listen to what he has to say, because he knows how to say it. And he is going to talk to us about vector databases, and basically we're going to dive into the realm of AI, and I think that's a very, very good way to open today's talk. So I'm just going to hand it over to Devlin.
Oh, thank you, Stefan, for that introduction. I'm now nervous because I'm saying big things, but yeah. Okay, so the slides are up. Thank you very much, guys. I think you came to the right place. There's more seats here, by the way. So moving on. Yeah, I came from Manila, Philippines. I moved to Oslo, Norway 5 years ago. And during pandemic, I couldn't go back to my family in Manila, so I decided to make myself more productive by writing a book, then followed by another one, and followed by another one. So yeah, just a quick intro about me. So this topic is about the rise of vector databases and a design pattern or an architectural pattern that normally was used along with the vector database. It is something new, which is, that's why I said earlier that you came to the right place, because AI is not going anywhere. I mean, it's becoming bigger and bigger each day. So I'm here to help you decide also whether to fine-tune a model or to use an architectural design. That's RAG. So this is more on the architectural design, because the other one has some fine-tuning, has pros and cons. So specifically, the Retrieval-Augmented Generation, that's architectural that I'm talking about. And it has some data source, like database, PDFs, text, where information keeps on updating. Like, for example, article gets updated every day, or conversation between a chatbot and you. For the fine-tuning, which is I'm not gonna discuss anything. It's for past data, and industry specific, and it's good. It's faster than RUG, but has cut off, and I say cut off, just like ChatGPT. When you search, when you ask ChatGPT the date it was trained, or like what's the date of your training, like your training data, it will just say it's October 2023. So today it's November already, so it's already like 1 year is missing. So anything that's new, this ChatGPT doesn't know, because all ChatGPT now, or all GPT now has this October 2023 knowledge only up to that. So agenda, here are the topics that I will discuss in my presentation about vector database and RAG. We have gonna do some demo also, and then gonna summarize it in the end. So keyword, just to differentiate, keyword search. This method retrieves documents that contain exact matches or close variations of the terms in the query, and we have this new one, semantic search. This is what I'm more focusing now. This method retrieves documents that are conceptually similar to the query, even if they don't contain the exact terms, like synonyms, like sea versus ocean. In semantic search, they're both the same. So it relies on semantic understanding of the content. I'm gonna do a quick demo here just to give you like where this semantic search is going to be applied when you start working. So I have this a typical, wait, I need to screen mirror. Good. So this is a typical pharmacy online, like Apothec, something like that. I'm gonna search eye pain. Okay, so the eye pain, when I search eye pain, it's giving me skin heat pads, antiseptic, antibiotic, a cream. It's for the fever, headache. So it's looking for exact search, like eye pain, right? This is your keyword search base. Let's go to the semantic. Let's go eye pain, generate. Something wrong, that's good. Let's refresh it. So this is just like a web page that it's intended for. This is not a real pharmacy, online pharmacy, right? Let's just generate. Yes, it has some, but let's see. Yeah, we have, okay, there we go, good. So vision, so eye is like, has synonyms of vision, ocular also, right? Eye, bright. So you would see that it's this is different from keywords search. This is semantics. So like ocular is similar with so that's why semantic search. So this is the two big differences between the keyword text-based search and semantic search. And this semantic is also can be used in a recommendation layer. For example, in Netflix, like category of like horror or suspense, something like that. And then also what you've clicked before, what you've watched before. And even if you don't do anything, if your profile is similar to like a guy, a 20-year-old guy from this place, and you have the similar profile, it's gonna give you also the same, like, you know, that's how it works. So this is the use cases of this semantic search. We can now move to the slides. We're gonna do extra demo again later. So what is a vector? So vector is just an array of numbers. In mathematics, a vector is a quantity that has both magnitude and direction. It looks simple. You can write it. You can hard code this in your code or any programming language. So it's like longitude and latitude in Google Maps, right? But it's not just two numbers. It's like really big. It's hard to imagine. So an embedding, again, this is a specific type of vector representation where high dimensional data is mapped to vectors of significantly lower dimensions. It's hard when you say like high dimensional, what the hell is that, right? So just to give you more analogy here, so low dimension, dimensional space, just like a Lego brick, you have these three attributes of descriptions, red small, with 6 studs, right? High dimensional is like this, one blue piece to the left of these hundreds of thousands of these Lego bricks. So high dimensional is like mind-blowing to realize how huge it is. So that's what the like embeddings, this vector is. So just think of it again, you know, an array of numbers with meanings. The idea is to capture the semantic meaning of the data in a dense, you know, this vector form where similar terms are placed together, you know, closer together in the vector space. So the process is that you need an embedding model. So this is a machine learning model. This can be open source like E5 based V2 or closed source like text embedding ADA in OpenAI from OpenAI. As you can see here, these are, let's say, unstructured, the images, audio, video, and then you have this text also. Then send it to the embedding model to process it and generate embeddings from it. It's just making this vector for these images, audio, video, text. Now we have embeddings, right? Because of this model, we need a system where we can store embeddings and the data that the embeddings, you know, represent. It's a representation. So a relational database is built to store structured data, right, in columns and rows. We are not going to use this for saving the embeddings. Doesn't make sense. It doesn't fit there. What about NoSQL? Document database is a NoSQL database that focuses on storing, retrieving, and managing document-oriented information. It doesn't fit there also, right? It's not good. So what we need is this. A vector database is a specialized database where you can store many vectors alongside. So when you say alongside, you're storing the vectors and the images, the videos, the text, alongside. It's a structured and unstructured data, and then retrieve them when needed. So you're retrieving both of them, the structured and unstructured. And here's a better way of looking at this. So while storing the vector embeddings, the embeddings will be grouped depending on how closely the words are related. Let's say your query, for example, a desktop, might bring a MacBook and laptop because they are all personal computers or gadgets. Let's say thyme, rosemary, and oregano are located in the herbs area because these are herbs. This is like, again, the DPS, that the embeddings are like latitude and longitude, right, coordinates. But the array have hundreds of elements inside of it. This is vector database, and there are several things that you must know to have performant database. So we have this vector indexing, involves organizing and structuring high-dimensional data, typically vectors, to facilitate efficient querying. It's about how the data is stored and accessed. And we have these KD trees, bold trees, hashing. There's so many algorithms here for indexing. What's the point of this? Why there's so many? In this vector database and embeddings, there's a trade-off, by the way. I mentioned earlier similarity, right? And when you search something, it might give you like not 100% correct. So there's a trade-off here. The trade-off here is, can you give me like really, really correct, but in expense of, it's high dimensional, right? So it's going to scan this enormous data just to give you the correct response. What if I want something that's very, very fast, very quickly? The trade-off there, if you want it very, very quickly, very, very fast to respond from this AI, the trade-off is it's not, it's not that 100%, or I would say sometimes it's not correct, or sometimes it's not that exact match that you're looking for. So that's a trade-off. Is speed, and then trading it with the accuracy is not so good, or very accurate but slow. So that's why they have these different algorithms. Also, and indexing also to query, like for example, images or text-based or videos or whatever. Yeah, so that's, I'm not gonna go deep with this, just giving you why is it like that, right? Search algorithms. So are the techniques to retrieve the most relevant vectors from the database in response to a query. It's about how the data is queried and retrieved. We have this KNN, and then ANN. I'm not gonna go deep here. So again, it's about trade-off and what type of data you're retrieving and storing and embedding. So, this is good. This is like how vector database gets the result from the data it's storing, the embeddings. This is called distance metrics. So if you were if you went to college or university, had this math courses or subjects, this pretty much math. So distance metrics, again, are used to determine the similarity or dissimilarity between data points, which are the vectors. And here are the standard distance metrics. Euclidean distance, it's the ordinary straight line distance between 2 points in Euclidean space. For vectors, it's the square root of the sum of square differences between corresponding elements. This is good for image similarity. Cosine similarity measures the cosine angle between two vectors. It determines whether vectors are pointing in roughly the same direction. This is good for text concepts. And we have dot product, also known as that scalar. That is for, very versatile. It's both for image and text. You'll see them in action later in the demo. Vendors, don't have much time. There's so many vendors you can choose here. Pinecone, Vivate, Qdrant, Milvus. There's like open source and closed source. Chroma, LanceDB, Vespa, Vald, and then Elasticsearch, Redis, and then pgvector, which is an extension you can use in Postgre. So these databases offer the advantage of integrating vector search functionality into existing data stores, Elasticsearch and Redis. I would recommend trying all of them before deciding which one to choose, because each one of them has different developer experience, in my opinion. So it's just like trying, oh, this is really good, and the docs are really good. So sometimes that's how you decide, right? And of course, how efficient it is in some aspect or area. There are also some tooling like Relary, and will analyze your results using metrics like rank-aware methods, allowing you to compare the performance of each configuration, right? Yeah, so roles of vector databases in AI applications. Now we're done with explaining what is a vector database. Let's see how it can help AI applications. Just to some basic things here, like what is an LLM? Large language models are machine learning models trained to predict the next word of a sentence or predict a sentence. LLM is not, it doesn't know anything in the data. It's not storing any data. It's just scanned the whole internet, and it was trained for that. So just to give you a good example, yeah, again, LLM, it's just predicting the next. It's just imagine it's someone who's really know English. So it can predict when you're like in the middle of a sentence, it can predict what is the next word that you're going to use. It's not capable of remembering anything in like a data or database. So that's LLM. And they have shortcomings. Maybe I could share something like what I did. So what I did, this is wrong, and then don't do what I did. I asked GPT, which is stupid, about a legal document. And I'm supposed to travel to Chile next week. And my mistake is I asked GPT, as a Filipino passport holder, do I need a tourist visa to go to Chile? And the GPT says, no, you don't. And I was like, okay, that's good. Because I'm lazy. I don't want to like Google and there's like a bunch of these, because that's what GPT is, right? It's just you don't need to like click any link in the Google search. And then after a few months, and I want to check again, right? And this time not GPT. Then I search Google if I need this like Filipino and then tourist visa, and says I need to. Now I'm fucked. now I couldn't go to Chile because I don't have this much time, because the application might take 2 months that they're holding my passport, and I don't want to deal with that. Like, what? So, but it might be possible if like 8 months prior to that, but it's like I have 1 month, and then that's too risky. So don't be like me, okay? Don't ask GPT for legal documents. That's the shortcoming of LLM. It invents things, right? That's why you're here. I'm gonna teach you how to fix that. If you're building an application and then you want to prevent it from making up things. So this is why RAG, the design pattern, and vector database comes in. So custom model, fine-tuning. Custom model, very expensive. Fine-tuning, also expensive. And again, it's not for the like frequently updating data. So we have this RAG, and it looks like this. So you have this user sending query, right? And then your query will be converted into embeddings first. And I'm going to tell you why. And then going there, and then it will go to the vector database for querying. What is that? Going there. And then your query is now will be sent to the OpenAI or to this any GPT-capable generative AI, along with the response from the vector database. So that's what's happening there. Your original sentence or question or whatever is not being sent alone. It's being sent also with data coming from the vector database. And this is the design pattern here now. It doesn't go here, query, go straight here. No. We need this because we have text, we have PDF, maybe we have articles, right? And then those are like being saved here, and now your you're gonna do like semantic search. That's why you have this fact now. From inventing things like hallucination, no. Now you have this fact data. You cannot invent things because you have this true data now that you can use. So basically, you're just asking ChatGPT. You already have this, the result that you want from this vector database. The job of the job of LLM or this natural language processing is to talk to you in a human-like way. It could be like you can use it right away. You can use it. But AI works like that. It acts like a real person to talk to you. It just uses the data, and then you can chat or whatever, you can ask questions. So that's the point of this AI here, and then this one. So, yeah. Yeah, demo again. Let's see. If I do this. Oh, yeah. So this is just a simple, vector database first, and then we're gonna go with a RAG. Vector database, run a quick here. This is Jupyter on VS Code using Python, and I already run this. That's why you have these logs. We're importing QDRUT. This is the vector database, and we have this client, and it's gonna send it in the cloud. This is a cloud base. Sentence transformer, this is the one that's gonna do the embedding, the vectorization, the converting into numbers. And we have this model name or Packt. This is just a type of this sentence transformer. Structured data. So let's say this is from the database, right? And these are actually like books and movies. So we have this sample data here. And then API keys, I already deleted it. So I'm just going to give it a name, like my books, right? And that's the collection name. Collection name, models, vector params, sentence embedding dimensions, distance, cosine. This is what I mentioned earlier, like distance metrics, right? And then after that, we need to push it to the database. We need the name, so it has name. Collection name is my books. Points. This is the data. This is structured data, right? See, when you hover it. Encoding, converted it to vector, and then gonna be payload. So yeah, data, encode it into vector, then push it into database with this name. And then you have a query here, movies about meals, okay. And then the vector database cannot use this alone. To do a search in the vector database, because why? This is not an embedding. This is like an English word, right? It has to be numbers. So you need to convert this into vector. It's going to be vector to vector, not words to vector, right, when doing a search in the vector database. So you have to convert it first into a vector. I'm going to limit with 5 results. Otherwise, it's going to give me the whole thing with this. And then hits. This is the score. This is what I'm talking about, accuracy. 5 results, as you can see here, about meals. And then it's giving me recipe, food. Meals are related to food. Recipe, should eat. See, you see that it's semantic. What is restaurants? I didn't search for restaurant, but it's giving me things about restaurant because I asked for meals about movie about meals. And what's funny here? Why is this alien here? Aliens gonna eat me or what? Why? Okay. The score is low, and the other one is high. So what is this score? This is a score like the accuracy, and there's no right and wrong here. It's just, if I were you, I'm just gonna ask the QA team or the quality assurance or product owner, are these score or these results okay with you? So, and then if most of the time they say yes, this is okay, this is okay already, then you can set the score. I'm just interested in score 0.5 more than like this. So it's up to you. There's no like, it has to be this score, right? So that's for the vector database. The RAG here, just gonna give you an example of not using RAG. When is 294 UFC going to happen? UFC is an MMA sports. So the UFC does not have an event. This is the response from the GPT. Does not have an event numbered 294 currently scheduled. The next event is 249. What? Today is 2023, 2024. It doesn't know that it's 2024, right? Doesn't know it's, that's not using RAG. Another one, why the main card of 294 UFC fight was canceled. The main card of 294 was canceled due to multiple fighters testing positive for COVID-19. This is hallucination. The UFC decided to cancel the event in order to prioritize. Because if you search it in, it's because Charles Oliveira, let's say this is what I got from an article, and I convert it here. And if you Google it, actually, it's Charles Oliveira had an injury, that's why it didn't happen. But this stupid AI is telling me because of COVID, like what? So this is hallucination, right? And as a part of the engineering the solution for your company or product, you need to stop the AI for the generative AI to do this hallucination to your customer. You don't want any trouble from your customer. You're gonna get mad if you said this is, but it's not that. So that's why we need, see here, be concise. This is now the template, by the way. Prompt template. This is how you're going to write it in real world. This is just an example. Act as a search copilot, be helpful and informative, then putting them line based on the user's query below. This is the user's query, why the main card of 294 was canceled. Here's the information about the query. It has the following information. The data, the fact. The facts are here. So you cannot lie, you cannot invent things, right? And note, you can put some note here. What's my note here? Be concise, be short. Don't say the whole story. So here it is. The main card of UFC was canceled due to Charles Oliveira suffering serious laceration that forced him to withdraw from the event. So as a this guy replacement. So this is how you would do it in preventing generative AI to invent things for your application. You don't want that, right? Using RAG without data, also here. Let's say it cannot find anything. Let's say this is the result from vector database. No information found. It's empty. Couldn't find anything. Couldn't find any good scores in the result. So what you can do is you tell them, and then it's going to respond. Unfortunately, there's currently no information available on why the main card of the 294 UFC was canceled. It is best to check official UFC channels or news outlets. So this is from the generative AI. Okay, hope you have an understanding why you're doing this vector database and this RAG retrieval augmentation generation. Let's move to the slides to finish this off. Good of time. So You can combine it with that keyword text search like Elastic to make it more, because sometimes you have like searching for emails, right, or numbers. Hybrid agentic, this is new. I would highly encourage you to do this. This is the get more accurate response from, let's say, complex information retrieval, like 3 sentences with each sentence has its own topic, but you would need a framework here in order to implement it properly, such as Llama, Index, LangGraph, or CrewAI. Summary, you have this, you've learned vector database, embeddings, RAG, and then there are limitations, right? Don't have much time. This is the repository vector database representation. You can take a picture of this if you want to see this. You don't have to run it because the response is also there. That's what's good about Jupyter. Resources. Also, it's very interesting to read this because this is the future of our development. Full stack and then plus AI, becoming an AI engineer, right? There's separation, data scientist, and we are in this AI engineering. So thank you very much. I hope you learned a lot from this quick talk. And yeah, give yourself a round of applause.
Thank you very much, Devlin. This was very informative and in some way abstract. Does anybody have a quick question? Because we're kind of out of time.
Oh, yes.
Is it possible to store different types of data in the same vector database? Let's say that I want to store images and text. Can I make an embed out of this content and store in the same vector, or is it recommended to make different database for this case?
Now it depends on what type of database. Some databases are capable of doing that you can store images, videos, or just TXT files or whatever. And the trick there is you would need different models also. And sometimes models are paid, closed source or open source. You just have to find a model that is appropriate for example, MP4, something like that, MKV. Yeah, and then save it in a same database so you don't have to deal with other database. That's good. Yeah, that's.
Thanks, everybody. Let's catch up here in 15 minutes so we continue with the other talk. Thanks, everyone.
Hey, guys.